Okay. Uh, okay. Good morning once again. So I was talking about the topic in the next topic in the module 5, that is NQ problem, right? NQ problem. So what is backtracking? We already know the backtracking is nothing but again finding a solution to the sub problems. But this kind of problems is basically applied to all other problems, irrespective of optimization problems or something like this, right? Uh, so there we also see how will we implement a backtracking using a state space tree, that also we saw in the last class. Fine. So let us move to the next topic. So what is the next topic here? As I told, it is uh, queen problem. Okay, n queen problem. So what is this problem is all about? What is the problem statement here is? The problem statement in NQ problem says that we have to, there are n queens which is present, and on an n cross n chessboard, you know what is, I mean, we all know well how to play chess, correct? So that is 8 cross 8. So given any n cross n chessboard, fine, you need to place all n queens. If there is say for example 8 cross 8, correct? So how many queens will be given? 8 queens will be given, correct? So that is the condition here. So for any n cross n chessboard, okay, given n queens, you need to place n queens in such a way that no two queens attack each other. Okay, no two queens attack each other. So when will you call the two queens attack each other? When they are in the, or being present in the same row, or it is present in the same column, or in the same diagonal. Am I clear here? So when will you call two queens or attack each other? Whenever the two queens are in the same row. So for example, if it is here, if this particular queen is present here, then these two queens are in attack, correct? So which means the no two queens should be in the same row, in the same column, or diagonal also. Suppose if you place this particular queen here, again there is an attack. So this is all about the problem. I hope you understood the problem, correct? What is the problem statement here? We need to place all n queens in a n cross n chessboard such that we need to avoid attack between the two queens by being in the same row or not same column or a same diagonal. This is clear? Am I clear with this? That is what it here this is. No two queens can be placed in same row, same column, and same diagonal. So this is an example. If you see here, no two queens are in attack because it has been placed in such a way that um, uh, uh, it is not placed in the same row, same column, or the same diagonal. So for any given n cross n, you are able to place the queens in this order. So this type of problems can be solved using using a backtracking approach. Okay, using a backtracking approach. So what will we do? Okay, first to start this, again go to the next one. If it is not feasible one, again go back, again track, right? Backtracking has to be done, again go back, something like this. So we'll see how to solve this problem. So this is all about this the problem definition, okay, or the problem description. So next, there is something called explicit constraint and the implicit constraint. In the last class, I don't know whether I remember whether we have seen this or not. So I'll just tell you what is this explicit constraint and the implicit constraint is all about. Explicit constraint is nothing but, okay, explicit constraint is nothing but rules, okay, it is a rules that restrict each xi here is nothing but an object what we're talking about, correct? So each xi, it restricts each xi to take on the values, it should take a values only from a given set. Am I clear? So this is the explicit constraint. So what is this all about? Explicit constraint says it is nothing, explicit constraint is nothing but a rule which restricts the xi to take only the value from the given set. That is explicit constraint. So what is implicit constraint? Again, it is a set of rules that determine which of the tuples in the solution space. We know now we will write what you can say, we will write this in terms of table format, correct? So each of these tuple, which means each of these particular tuples in the given table is the solution or is which satisfies the given criteria. Is am I clear? So implicit constraint is nothing but rules that determine which of the tuples in the solution space satisfies the constraint. Okay, first you will construct the solution space. First you will construct the number of solutions. Now what we are doing, each and every solutions we are checking whether it is satisfied with the constraint or not. So these rules is nothing but implicit constraint. Am I clear? So if you remember the previous class topic, we were discussing about placing an objects, correct? So each and every object depends on each other or something like this, correct? We were talking about that. So no, we were talking about placing an object, the balls, correct? We were talking about placing the balls, placing the balls. Okay, we will place the balls in a number of orders. So that is okay. That is an explicit constraint. In I mean, n number of ways you will place it. Say, for example, B1, B2, B3, then B2, B3. All 6 possible solutions is a so a set of solutions. Now, out of that possible solutions, finding the one which is feasible. Okay, how will you find the solution if it is feasible based on the rules? That rules has been explained by a implicit constraint. Okay, am I clear now? Okay. So now we'll see what is explicit constraint and implicit constraint for a n-queen problem. Okay. So explicit constraint is nothing but what is nothing but we need to, for any xi, we need to get the value only from a set. That is what is your explicit constraint. So here it says about all n queen must be placed on a chessboard in the column 1 to n. Okay, in the column 1 to n. So given, say, your chessboard where all the queens should be placed only in the given the columns only in the chessboards in the column say 1 to n, and xi belongs to s, that is a set where it is nothing but 1 to n. So that is what we told, it should have values only between, only in the given set. So this is a given set 1 to n, so xi can take only values from 1 to n. So this is explicit constraint. Implicit constraint is what? Implicit constraint, as I already told, what are the rules which will tell you in order to identify the, I mean, the constraints which will talk about the feasible solution. So, what is the constraint? No two queens can be on the same row, no two queens can be on the same column, no two queens can be on the same diagonal. So, this is the implicit constraint. Am I clear now? Okay. Now there is that's what in detail we will see what is this row. We were talking about no two queens should be placed in the same row, same column, all those things, right? That is explained in another way. That is horizontal attack, vertical attack, and the diagonal attack. So what is this horizontal attack? Horizontal attack is nothing but rows. So row wise attacking is how will you avoid a row wise attack? By placing each and every queen in a separate, by placing each and every queen in a separate rows, correct? So you can write q3 somewhere here. Okay, you can write q3 here, q4, something like this, correct? So this is how you will avoid horizontal attack. Avoid horizontal attack. Horizontal is nothing but row wise attack. How will you avoiding it? By placing each and every queen in a separate rows. Am I clear here? Okay. So the next one is vertical attack. Vertical attack is nothing but the column wise. How will you avoid column wise attack? It is just by avoid placing the each and every queen in a same column. So avoid placing the queens in a same column. So this is an example. If you see here, correct? So this can be, this has been generalized here. How will you generalize here? X of I, if it is equal to x of k. Okay, so x of I is equal to x of k, which means we know each and every table here is, I mean, the rows and columns has been numbered, correct? So okay, 1 2 3 4, correct? So 1, 2, 3, 4, and this has been numbered. Okay, so x of I, if it is equal to, I mean, this implies it is in the same column. Am I clear? So, am I clear here? Okay, just to go through this one. So, I comma x of I comma x of I means the position of I here indicates the ith queen. Okay, ith queen in a row I and a column. So, x of I indicates basically a column. X of I indicates a column. So, even here x of I is nothing but a column. So I to k, I is nothing but I to k is nothing but queens. This is a queen number. X of some value indicates that particular column. So x of I, which means the column of ith queen is 1 equal to, according to this example I'm talking about. So column, the position of the queen k is also first column. So both are equal, first column and first column. So it is equal. So avoid such conditions, avoid such conditions. So that is what it says here. So x of I is equal to x of k to be avoided. Am I clear? So that is what which says here 1 comma 1. 1 comma 1 is for this one. It's basically something like this, and 4 comma 1. So here k here indicates the fourth queen. Correct? So fourth queen in the first column, first queen in the first column. So here the columns are same, right? So x of k and x of k both are same. So it is to be avoided. Am I clear with this? So just go through this once. Basically, it talks about vertical attack, talks about avoid placing the queens in the same column. Okay. So the next one is a diagonal attack. Okay, the first concept under diagonal attack is top left corner to the bottom right, top left to the bottom right. Okay, so how will you avoid this is basically the difference between the row value and the column value. Is it clear? The difference between the row value and the column value is same. If it is same, you need to avoid this. So here, what did they write here? So here they wrote something like this. Suppose in this example we are considered 4 cross 4 queen problem. Correct. So 1, 2, 3, 4, 1, 2, 3, 4. So this particular position indicates 1 comma 1. This is 1 comma 2, 1 comma 3. So they have written the values here. So 1 comma 1, 1 comma 2, 1 comma 3, and 1 comma 4. So now if I place queen 1 here and queen 2 here, now it is, we can easily observe it is diagonal one, correct? So we should avoid this because there is an attack between these two queens. We need to avoid this. But how will you implement this actually? Correct. How will you implement? That is using this particular difference by using this particular difference. So what is this I minus x of I? So we know 1 comma 3, this is I and this is x of I, correct? So 1 minus x of I will give you what? Will give you this is you should take only the positive value. So 1 minus 3 is usually 2. So 2, and this k minus x of I, 2 comma 4, 2 comma 4, this is k and this is x of k. So 2 minus 4 is also 2. So 2 is equal to 2, which means you need to avoid this. Is this is clear? Okay, am I clear with this? Okay, now consider if I place a queen somewhere here. Okay, it's not possible. I'll just show you. Okay, if I place a queen somewhere here, correct? So this will give you what? 3 comma 2 and 4 and 3. What is the value here? Difference, it is 1 and 1. So these both are same, correct? You should avoid. Am I clear here? So that is what this formula gives me. So if you get the values, if both are equal, then that should be avoided. Placing the queens in such order should be avoided. Am I clear? Now if you observe, what happens if I place queen here and queen 2? This is also diagonal one, but that should be avoided, correct? So, but as I already told, this will satisfy only for a top left corner to the bottom right. So this is not possible because if you see here, 3 comma 2 and 4 comma 1, the difference here is 1 and the difference here is, this is not same. According to our formula, yes, okay, this is fine. I can place this, but If you see it is in diagonal order, so you should avoid this, correct? So for that, we have another set of formula for a top right corner to the bottom left corner, top right corner to the bottom left corner. What you should do, it is just the reverse of that, correct? Adding both. Am I clear with this? So same thing, whatever you did previously for the same formula, we are adding now. So x, instead of x minus sorry, I minus x of I, we are adding those two. Am I clear now? So take these two examples only now. That's what I was showing you in the previous slide. So 3 comma 2 and 4 comma 1. So adding those two will give you 3 comma 2, addition of these two will give you 5. 4 comma 1, the addition will give you 5. So both are equal. So you need to avoid this. Am I clear now? Okay. So the one which we saw previous one is for the top left corner to the bottom right corner. So now this addition is basically for a top right corner to the bottom left corner. Am I clear till now? Any doubts? Okay. So this is one more constraint here. You need to avoid this. And one more, it need not to be the adjacent one. Okay, it can be in any position. So even this is also diagonal. The one which is highlighted here, even that is also a diagonal one, correct? So even that should be avoided because you cannot place this in a diagonal order. Even this should be avoided. So that is why even this condition holds true in that case also. So 1 comma 3 and 3 comma 1 both will give you 4 and 4. Both are equal. You should avoid placing it. Am I clear till now? Fine. Fine. Okay. Now, as I already told, okay, before going to take one example and see how the solution works. Okay, how the solution works, we need to go for, we'll check for the algorithm and then we'll go solve one problem and we'll see how actually backtracking helps here in solving n queen problem. Fine. So the algorithm n queen of k comma n, which talks about for I is equal to 1 to n, okay, if of k comma I, so that is that is a different function. It usually returns false or true. If place of k comma I is true, okay, if place of k comma I is true, what you should do, x of k is equal to 1, you should 1, and if k is equal to n, then you're going to write this, which means yes, this is a correct one. I can use this as a correct position. Okay, I can use this as a correct position. Else what you need to do, else you need to call, if this is not the condition, whatever place of I, if it is not, if it is false, you should call these nq repeatedly. Okay, you should call these nqs repeatedly. So that is what is your algorithm talks about. So what is this place of I now? So what is this place of k comma I? Place of k comma I, where what we are doing here. Okay, so okay, so what is this place of I? It returns true if a queen can be placed in the kth row and ith column. Okay, this k here indicates row and I here indicates the column. Am I clear now? So this particular function, that is place of k comma I, this is an algorithm, also algorithm, correct? So it returns true if a queen, sorry, if a queen can be placed in a kth row and the ith column. Okay, it returns true. Otherwise, it returns false. Am I clear here? Okay. Now, what is this x here? It is nothing but an array. Correct? X is nothing but an array whose first k minus 1 a value have been set. Okay, k minus whose first k minus 1 values has to be set here. Okay, what is this ABS here? ABS usually returns ABS. We already know it is nothing but absolute value of R. Correct? So ABS is an absolute value because sometimes you will get negative also. So I need to avoid such cases. So that is why absolute has been used. Okay, now go for the for loop. It starts from 1 to k minus 1 object. That is what I told. Only first k minus 1 values have to be used from the set. Okay. Now what we are doing in this if condition, if x of I is equal to I, if x of I is equal to I is, if two elements are in the same column or not, we are checking. Am I clear? So if x of I comma j indicates whether if two what is that, queens are in the same column or not, we are checking. Or, okay, or absolute of this indicates what, whether we, what we are doing here is if both the queens are in the same diagonal or not, we are checking here. Okay, if it is diagonal or not, we are checking. That is what we told, right? The previous formulas, if you see here, this one. So or here. So the same thing I am writing in terms of algorithm. So this is a place. So if it is possible, if it is not possible, then you can say, okay, it's not possible. Otherwise it returns true. Okay, if it is possible to place that particular q in, I mean q in the sorry, queen, possible to place a particular queen in the chessboard, that particular row and column. Am I clear? So one thing we should remember, k comma I is nothing but this is represents the ith row and the sorry, kth row and the ith column. Okay, so start from j, which starts from I to k minus 1. Why? Because k minus 1, it starts from 1, so it is k minus 1. So k is what? Number of rows. X of j, if it is x of j, usually gives you the column wise. If it is equal to I, which means if both are equal, if the column and row are equal or not, you're checking. Otherwise, you're checking for a diagonal one. Return if it is not possible. So if it is not possible, if it is not true, you are calling this again for the next column of I mean for the next set of queen. So here basically k indicates the set of queens. Okay, so what is the output of this algorithm? Usually it prints, that is why we wrote right here. So it prints all the possible placements of n queens. Okay, all the possible placements or a position of n queens in what, in where, n cross n chessboard. Okay, so that you should avoid attacking also. The attacking should also be avoided. So that is the output of this particular. For example, if you consider n cross, sorry, 4 cross 4 queen, so q1, that is queen 1, queen 2, q3. Suppose if it is placed in 2, if it is placed in third position, if it is placed in fourth and first or something like this. This is one possible. So this is the output of the n queen algorithm. Okay, the position of each and every queen in a n cross n chessboard. Okay, that is the output. We'll see with an example now. Okay, so as I already told, let us start with let us take an example of 4 cross 4 matrix, right, which means 4 queen problem, because we are considered 4 queens. So each and here, each and every correct, each and every row here indicates a queen. This is correct? So what shall we do here in this particular, we know that there is a state space tree for 4 queens. This is a state space tree. Initially what will we do is we start with the empty board. If you see here, nothing has been placed here. We start with the empty board and then place queen 1 in a first possible one position is what, this one, correct? So first possible position, place the first queen there. That is nothing but row 1 and column 1. So that is what, 1 and 1, row 1 and column 1. Then we try to fit the queen 2 in the next column, correct? So in the next column or the next row, you should start with the next row. Okay, then in this example, what they were doing, after trying, they have tried so many the examples. So for example, this can be placed as it is. So now if I try to place in here, if I try to place in the second row and the second column, it's not possible because there is an attack. So you should stop, you should not use it, correct? So it is wrong. That is why which has been shown here x, which is, it is you dead end, correct? That this we discussed in the last class. So it is a dead end, so you should stop there, you should not consider. So this is not possible. Go for the next one. Yes, it is possible because there is no attack, it is not diagonal one also, it is not placed in same row, same column also, it is acceptable. So that is why I have written here. Okay, so the next possibility is this one, q and fourth row. So this is basically for something like this, q and in the first uh, column and first row, second row and the first column, so it is not possible. Next, this is for the first second row and the second column, even that is not possible because we were having an attack. So the next one is, it's something like this, it could goes on something like this. Am I clear? This is just increment the row wise. So increment row wise, start placing the queen in a column wise, so first column, second column, third column. Okay, so next, go for the next one. Start placing a queen 3, correct? So you may get the all results, so something like this. Again, for a for placing a 3, this is possible one. So I'll just show you with these one. Okay, so with these one, so I cannot place q here, q3 here, because it is in the same column, so it is not possible. I cannot write q3 here because it is what you can say, it is diagonal one, so it is not acceptable. I cannot write q here, q3 here, because it is in the same column. I cannot write q here because it is in the diagonal one. So all these things are the dead end, that is why it is dead end. Am I clear? Okay, next, go for these particular set and now check it out. Okay, now this take these particular thing and check it out. Yes, according to this I can place q3, right? So I cannot okay, I cannot write q here, it's not possible. I can write q here because a condition is satisfied, so I can write q here, and I cannot write q here, I cannot write q here. So only possibility is the second column, so that is why I have written it is acceptable one. The remaining is not accepted, so it is dead end. Clear? So again, with these, try to fit the q4. How will you get fit q4? So if I write here, it is not correct. If I write q4 here, it is not correct. If I write q4, not correct, not correct. So all these are dead end. Am I clear? So we didn't get any solution here. So it's wrong placing the queen 1 in the first column and the first row. Next, go for the next alternative. So what is the next alternative? Place the queen 1 in the first row and the second column. So that is why we have written queen here, q here. Now check for the next possibility. Okay, suppose, okay, start with q2 now, because we know each and every queen should be placed in each and every row, single separate rows. Okay, so queen 1 is placed in a first row and the second column. Check with the queen 2. Queen 2, can I place in the second row and the first column? It is not possible because it is diagonal one, so there is an attack, so this is dead end. And try to fit here in the second row, second column, it is not possible because it is a dead end, because it is in the same column. Go for the next possibility. What is the next alternative here? It is q row 2 and the column 3. So even here it is a dead end, so not possible. What if I place in the next position, that is in the second row and the fourth column? It is acceptable because there is no attack, so this is acceptable. So I have written here correct. So all the 4 possibilities we tried, the last one is acceptable. So next, again we need to check it out for a queen 3 in a similar fashion. For a queen 3, try fitting it in the first column. Yes, it is possible because there is no attack, correct? Okay, so that is why this is written. What if I try writing it in, because we know backtracking, all the possible solutions should be noted down. We cannot stop here at this position saying yes, we got the solution. So go for the next alternative. Correct. So can we try to fit this queen 3 in the second column? It's not possible because already queen 1 is in the first same column. It's not possible, so it is a dead end. Okay, so the next possibility is, can we write it in the third column? No, it is possible because these both are diagonal, so it is a dead end. Can we write this with the next one? So it is a dead end, so stop. Only possibility is this. Correct? Okay. So with the solution whatever we got, try with the next one. Queen 4 we should place, correct, in the chessboard. So can we start with writing in a first column? Not acceptable. Start with the next column, not acceptable, so it is a dead end. Can we write in the third position? Yes, it is acceptable because nowhere we are feeling, we are satisfying with all the constraints. It is not placed in the same column, same row on the diagonal, so it is acceptable. I have written. Can we place in the fourth column? No, it is not possible because um, these both are in the same column. So only this is acceptable, correct? So what is the position? So if you observe, all the queens are placed in the matrix, n cross n matrix or a chessboard, correct? All the queens are placed by satisfying all the constraints. So here we should talk about the columns. So the queen 1 is placed in second column, queen 3 is placed in fourth column, queen 2, queen 3 is placed in first column, queen 4 is placed in third column. So this is the output. So again, I should, as I already told, you should not stop here, go with the next one. So what is the next one? The next possibility is the third column. We are done with second column, go for the third column. Am I clear? Similarly, go with the next column also. Did you understand this problem? So when will we get dead end? Whenever there is a constraint. You should stop there and you should continue with the next. Okay. So this is the two solutions. Actually, whatever which is given here is wrong, is what I feel. Solution. Okay, from the previous one, for the n queens problem, okay, instead of this, it is not this, it is this one, q in the second position, in this fourth position, this is in fifth position, and this is in fifth position. Let me write this. So here, 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 and here. So if you check it out, this is a correct one. So this is says 2 4 1 3 column wise I'm talking about, correct? So this is one possible solution. The next possible solution is 3 1 4 and 2, correct? 3 1 4 and 2. So 3 1 4 and 2. So these two are the possible solutions for a 4 queen problem. 4 queen problem, correct? So this is the two possible solutions. Am I clear? So shall we? Okay. So as a revision, I'm explaining. I was already told that this is a 4 cross 4 queen problem, that, or you can also call it as 4 queen problem. How will you get the solution for this? Let's start with the empty set. Now go for the, I'll just show you in a simpler form than which we saw in the last one. So this is just a simpler one. So I will just start with the first queen. If I start with the first queen, correct? So I mean first queen in the first position. I talk about first position. First queen in the first position. So yes, I can write here, correct, queen, and go for the next one. That is a queen 2. Queen 2, I can write it here in the second position. Can I write it in the second position, queen 2? It's not possible. So this is a dead end. Correct? So this is a dead end. So it is not possible. go for the next possibility. So can I write queen 3, queen 2 in the third position? Can I write queen 3 in the third position? Is it possible? I'll just check it out. Um, this I'm talking about this, right? So can I write queen 3, queen 2 in the third position? Yes, it is possible because nowhere we are finding. Now go for the next alternative. Can I write queen 3 can I write queen 3 in the first position? Not possible. In the first position it is not possible. In the second position it is not possible because there is a diagonal one, so it is not possible. In the third position, not possible because these both are same. In the fourth position also it is not possible, like because it is a diagonal one. So what I need to do, stop at this point, go back, and then replace this. So I can, which implies that I cannot have queen 2 in the second position, so you need to change it. Okay, did you get the point? So queen 1 we have already fixed. Queen 2, if we fix here, we cannot fit q3 anywhere. Correct? But we can write q3 here. Yes, that is acceptable. Okay, so till here it is fine. But we cannot write q4 anywhere. Correct? So q4 you cannot write here, you cannot write here, you cannot write here, you cannot write here. So what I need to do, go back and check whether can I place q3 such that I can fit q4. Okay, so can I write q3 here? Not possible. Right? q3 here, q3 here, not possible. Again, backtrack. Correct? So which implies q3, if you change q3, it is not possible. Go back, that is backtracking, change q2. Can I write q2 somewhere here?